Before we get started, we had one question in the chat about how to get the slides.
Okay. At the top of these slides, I put the URL to go to. I'm going to copy it into the chat. Now, at this location, there's a Python workbook, and there's also a version that is a PDF, so you don't have to actually run Python workbook if you don't want to, that you can see the slides and the values that would have come out if you executed it. So, for instance, here, I don't know if this will actually open. It does. You can see that basically it's the presentation. Okay, so let's get started. And then we're going to talk about Python and object-oriented development. And again, same place. So what is object-oriented development? Why do we care? Well, we should never serve the idle, but we should use it to make our life easier. So if you're doing object-orientedness and it doesn't seem to be what you need, then don't do it. But the reason we try to use object-oriented development is because problems get bigger, and when they get bigger, they're more difficult to remember how they all function, how they function together. So it's always a great way to organize your application. It attempts to simplify larger applications and their construction. And we really want to do that because programming is not that hard, but really good programming, really big programming is difficult. There are some principles of object-oriented development. Just to go over them, what we want to do is we want to encapsulate. We want to hide stuff that people don't need to see. So if we want something to print, then just print. We don't want to have to tell you all sorts of crazy details about the innards of the thing we're printing. We want to abstract things and provide ways of manipulating them without having to know anything explicitly about them. A good example would say we had a zoo and we had classes of animals. You know, we just want a method called feed the animal. We don't want to know about the details of how to do it because each animal handler knows how to feed this animal. So we don't have to tell him how to do it. We only have to tell him to do the feeding, for example. And then there's polymorphism, which allows us to put things, take a participating common collection of things and create some sort of specific behavior, or allow them to have a single behavior under many different circumstances. And those are sort of technical definitions. But basically, you just want your life to be easier by having fewer details in your application. So there are tools to do that. The first two tools that we'll talk about are objects and inheritance. You want to group your functionality based on real-world things because we all deal with real-world things every day. And inheritance gives us this ability to, as I said, extract the common behaviors out of the things and move them down into a lower level where people aren't necessarily bothered with them. So, for example, in a traditional development, if we were putting together something like a library catalog, real simple one, and we have books, magazines, and we have websites in our catalog, we would have a catalog that had all the different sources available. And then if we ever wanted to process them, let's say we wanted to print an entry out of the catalog, we would have to have some sort of statement that had a bunch of if statements. So this would be if the source is a book, do this, maybe else if do that, maybe else if do this, and each of these different handlings would get done based on the type. Now, the problem with this is I have to know the detail about each of those type of objects. But all I really want the object to do is print. So in object-oriented development, what we do is we move the printing inside of the object. And we do that by creating a base class that we're going to derive from. And it has a print method which gets overloaded by each of these these classes, and now they all implement a specific print. So these prints are these right here. And so now when I want to print, I can have a collection of things. All I have to do is say for sources, print. And while that doesn't look like that much of a great example, if you can imagine, once you've defined something, you can print it in all sorts of different places. And so you're reducing all those places where you had to manipulate with print into 2 lines from the 20 lines you had up above. So that's just to give you sort of a background of object-orientedness so that you sort of understand what we're trying to do. So if you have a frame of reference already, you've done C++ or Java or something else, that's great. So we're going to start moving into that sort of area. Remember that these are classes, and classes have attributes and methods. You can think of it sort of like a class as being a cookie cutter that makes cookies. So objects are cookies, and the cookie cutter is a class that makes cookies. And here's an example of a simple class. Class starts with a keyword, has a name, and I think I told you about the pass statement. Basically, the pass statement is a do nothing. So this is the simplest class you can have because it does absolutely 0. And if we print it, it prints something terribly ugly because Python doesn't really know how to print an object. Or a class, well, yeah, this is an object because this is the class, and this is an object of type class, if that makes sense. So the way that gets done, this line right here, the way this line down here happens is the book class uses a constructor, and it constructs a book of type class, and it uses this, which is called a constructor. So we can create that constructor. It can take any number of arguments. Unfortunately, we can only have one constructor unless we use, as we talked about before, args and k-args, kw-args, and that's how you would implement something that could take a number, any number of arguments. But in our case, let's say we don't know that yet. It only takes three parameters. Every class method, the first parameter is something called self. You can actually name it whatever you want, but what it is it's the thing you're making. So by the time you get into this under and it, you actually have the object that you were constructing from that class. And now I'm saying set the values of that object. And by taking the title and putting it into self title, I'm putting it into that particular object. Other things that we want to point out here is, notice that since self has an attribute that's underscore title and underscore author, underscore copyright, I've basically kind of given the user a hint that those are internal properties, that no one should change them. You don't access them directly. You're supposed to go through whatever the methods are. In other words, if I wanted people to get the title back out, I would have to create a method called get title or something like that. You can also create methods within there that manipulate the data that you have in your object. So in this case, if I have a book, I can call print citation on it, and I can then print the citation of that book in whatever format I want. So for instance, here I am, I'm making a book. I'm giving it the title, author, and copyright, which in this case is an int. And that gives me a book. And now I'm going to print the citation. So if we run this, we should see there's the citation. It looks a lot like the actual entry, but that's just because of the simplicity of the example, I guess. So the class above has those 3 attributes. I told you that. Because Python supports a dynamic typing, Their types are really not that important. And since the constructor defines them, we can guarantee that they exist. I could conceivably not define all of these here, or for that matter, I could do this. I could say self dot now if you call printed, if you call print citation, this object will now have an attribute called printed. In other words, objects just have attributes stuck on them whenever you want. If you want to make sure that they exist for every instance in every circumstance, you want to make sure they get assigned something within the init. Because otherwise you have to create code that will detect whether or not they're set. Because now, if I want to rely on the fact that printed is set, let's make it a public variable, a public attribute. Now I have to ask, is there one defined? And if there is, what's its value? I could have said false up here. And now by convention, only by convention, I can rely on the fact that printed always has some value. So we talked about the two methods. We talked about init. It's a special method. Notice that it has an underscore, which means we don't call it directly. We should never really call it directly. And in fact, it has two underscores, which means we are strongly discouraged from calling it. And I'm going to go over that down here just to make sure everybody understands that underscores have special meaning. By convention, a single underscore means you're, I have to quit clicking on this. And by convention, a single underscore means that you are discouraged from calling it. A double underscore means you should definitely not call it. It's very strongly concerned. But there's no such thing as private data in Python. So you could go in and reassign anything you want at any time. Now, syntactically, the underscores mean things as well. So for instance, you've seen that the underscore init is called by the Python constructor. So the thing that makes this object and then calls this method it's already constructed that book object. So whatever that is, that by convention, it will always attempt to make this call. And you'll see that there are many, many more examples of that later on, which I also put in an HTML file on my website called special method names, which is a long list, and we'll get to it if we run out of time, or if we don't run out of time. So here's a more complicated class. So we have a book. It has a citation type of book, which means this is, by the way, a class variable, which means it's assigned automatically to every different object that's a book that gets created. It's class scope. I could say uppercase book dot citation, well, underscore citation type, and it would tell me what kind it is. In this particular case, all of these methods can access it. Here's our constructor, very much like we had before. Print citation, pretty much kind of the same. These are new. These are decorators. They're called decorators. What they do is they implement a form of aspect-oriented programming. It wraps this method with something that lets it know that it's a class method. And a class method is a method that can be called on the class itself. I don't have to actually have a book. I can just do it on the book class. And we'll demonstrate it down below when we run it and look at what happens. But you can see it doesn't reference any of the particular instance data. It uses the class, which gets passed to it, and says, give me the name of that class. So basically I'm saying, print your name. Print the name of this class, which should be book. And then of course I have a static method. Static methods are like class methods, except that they don't get access to this class object and they just get called. So it's kind of like a method that sits here associated with this class, but you could just call it as though it were standalone. So I could have copied it out of the class and it wouldn't have much mattered either way. So down here, we're going to construct a book. Then we're going to set the private attribute, which I told you not to do. And I'm going to print it, and you'll see that it's set. And by the way, that I set it on the class. I didn't set it on a book. So what should happen at this point, I think, is everything that gets created, every book that gets created after that should now be a magazine. And so we'll call this the Mad Magazine. Okay, so now if we run this and we start talking about it. So the first thing is this is the print that says it's a magazine. Then we're going to print, let me match these up, static. Those are the same. Oh, okay, I see what I'm doing. So here, for instance, I can invoke the class method with the class or with an object. And the static methods, I can do the same, but the static method doesn't receive any class information whatsoever. So there's no class getting passed. And what would really be interesting is if it's a class method, there's a print citation. So if I do this, that ought to be a magazine. Oh, it doesn't say what kind it is, does it? Yeah, let me make them on here. Right here. I think I could just do it this way. Nope, can't do it that way. Oop. Yeah, see, now it says it's a magazine because we messed with the internal value. So we sort of hacked this class by changing its type. So, as I said, citation type is a class attribute. And I said it's private because we put an underbar in front of it, but you can still set it. And I showed you what would happen when you did that. Print name. We kind of went all through this, and I talked about the decorators. In fact, there's quite a lot of things you can do with decorators besides just set class method. You could write your own decorators in Python. So let's talk about inheritance. So we can create a class called a citable source. And in there, we're going to have a class variable called next number. What we're going to do is we're going to basically, every time an object gets created that's a citable source, it's going to get assigned another unique number. So it'll go from 1 to 2 to 3 to 4. And so, as you can see in the constructor for a citable source, when one gets created, we set its number to the citable source number, and then we increment it by 1. So it's a way of having a unique ID. And of course, we can ask whatever the citable source is, what's your number? And we can have a base implementation for print citation that just prints some stuff, just the number itself. So we can now create an unknown class type that's derived from citable source. And if we call print citation, it should just give us the number it was assigned, which based on this should be 1 if we instantiate one of these first. And then we can have a book that when it's a book, it prints a book type citation, which is the number, its unique number, its catalog number, so let's say, and then title, author, and copyright. And a magazine that has the same sort of information with volume. It's just a different kind of print. So if we instantiate them this way, unknown, book, and magazine, and then we print them, they should be 1, 2, and 3. And they should each use their own print, except for unknown, which should use the base print because it doesn't have a print defined. And as we can see, unknown, since it has absolutely no methods defined at all. Right here, it should use the default base, which is that. And the others have overridden and have their own print, and so they print accordingly. So what are the highlights here? Well, a class can define its base class by using brackets around at the end of the class name, like this. This is saying basically that book derives from citable source. The default base constructor will be called, unless you explicitly call it. You can actually do I think it's super. You can refer to the base constructor yourself and call it under certain conditions. Base class attributes and methods can be accessed either through the self variable or by using the function super. So you can say super dot and get into the base class values from your derived class. And using a base class allows us to create default behavior. As we've shown, we have a default behavior for the print, so that unknown will at least print something, even though I never defined anything. Now, that's your traditional object-oriented programming. But now there's more. We don't really need classes. Well, we need classes kind of, but we don't really need, well, we really don't even need classes. Because of polymorphism, you can define a method and just, as long as the class defines print citation, you can stick it in a collection that can call print citation. So in this case, there is no base class. Each of these classes defines a method like this. They're all the same, right? They have no argument. I can put them in a list and I can call them. It doesn't matter. Boom. And I'm not so sure if, I don't think I've ever done this, but I think you can have functions. You can have functions on a member, on a variable. So you can basically just put functions in a list and start calling them. As long as they're all the same signature and name, it doesn't matter. But they could be different implementations. Don't take my word on that. But I know you can use it with classes here. And as you can see, it called the right ones, and there's no complaint. So this is way simpler than even using classes, right? You don't have to build all that infrastructure around it that you had before, where you had a base class. And so that's what you call duck typing. And what it means is basically that if the type behaves like you want it to behave, then you can just call it. If it walks like a duck, quacks like a duck, it swims like a duck, it's a duck, which is why it's called duck typing. Now we're also going to talk about some object-orientedness, and I call it object-orientedness because it's information hiding, which is why it's important. You're hiding what's going on. So just to start you out, some of you may have seen this. It's a way of using files. You use the with statement. You say with open this file, and you're going to call the file as f, and then you can say f.read, and you can do all kinds of things with f, and when you're done, you don't have to close it. And it works because the with statement closes the file. Now, what is the with really doing? What it's doing is it's well, first of all, you're using the with statement because you're protecting the valuable resource, right? A file open in the operating system is something that you don't want to just let dangle. Python infrastructure can't clean it up because it's over in the OS. So that's why you want your what you call your precious resources. You have to be careful when you have to allocate and deallocate. You can use this. And this is what kind of happens right here. So essentially what's going to happen here is that when you use the with statement, the open does something when it starts. It sets up an ability to close itself. And when it leaves the scope of the with, it triggers something to do the cleanup. And what really happens is when you enter a with block, Python automatically calls a method called enter, which sets that with block up and sets up the thing that you're working with. In this case, it's a file. And then when you leave a with block, it automatically calls the exit of the thing you have. So we can use this, and they used it when they wrote the file manipulation code for Python. We can use it to create a timer. So what we're going to do is we're going to create a timer that behaves like this. With the timer as t, do something. And then when we come out of scope, we want it to automatically print a message about how long we've spent in that section. And the way we do that is we write a class called timer. It's got to have a constructor that doesn't have any arguments in this case. It has to have that magic function called enter. That in this case, when you call it, does nothing but get the current time and put it in a start member variable. Then we have to define an exit that takes a prescribed signature. You've got to have this as your signature. But what we're going to do with it is we're just going to take the current time, subtract the start time, and print how many seconds we were actually in there. So what happens is the with says, oh, you created this object. This is the object. I am going to call the enter on it and assign it to the value t. Then you're going to do some stuff. And when you come out of scope, I'm going to magically call the exit for you. So essentially when this runs, it does the equivalent of this right here. You create a timer, timer.enter, sleep for 2 seconds, timer.exit. And so when we run it, oops, stepped over it. We run it, take 2 seconds, take more than 2 seconds. Okay, I didn't, and there it goes. So it takes 2 seconds and it completes. They both executed. They both did basically the same thing. So why is the first one better? Why is this better than the other one? Well, obviously, it's shorter. The indentation makes it clear that what the scope of the timer is. And I don't have to forget to call, in this case, exit, or in the case of the file, close. Because you can imagine if I did that in a tight loop and had a lot of files open and close, I'd run out of file handles in Linux and things would go south after, oh, I don't know, a couple, 10, 5,000 file handles or something like that. And then the OS runs out of file handles and then everything crashes. So that's how you protect yourself from that. Now, we started to talk about this at the end of the last presentation, but for those who weren't here, we left out a portion of what we call polymorphism, and that is, how do we get the same behavior? How do we get different behavior? Let's see how to read this. Allows the creation of single behavior under many circumstances. So, for instance, how do we make a constructor that takes many arguments, many different arguments, something like that? And the way we do that is we use these two methods called start args and start kw args. And they're mostly used in function definitions. What they do is they allow you to pass variable number of arguments to a function. Variable means that you don't know beforehand how many arguments you have, so you will have to write the innards of your function in such a way that you can handle however many arguments come. And the star args is used to send non-keyword variable length number of arguments that are positional. And the KW args sends you a variable length of arguments that are key value paired. So you have the name and the value. So if we look at this one, for instance, I'm going to call this function just a traditional set of arguments. And I'm going to do that by putting them in a tuple. I've created a list of arguments, so I'm going to use the star args. In other words, this could be any length, and it will accept it. In fact, just for trends, let's put another one in there. This should not hurt anything. I lied. Why did I lie? Ah, look at that. It does match. Well, then I should be able to do that. Really? I lied. So this is just basically using a tuple to give you the same arguments. It's the same as this. There's not a lot of difference there, not a lot of flexibility. And yes, it's the same as just doing the parameter call. Now we can use KW args. We can create a keyword argument list, and we don't have to be in the same order. They don't have to be arg1, arg2, and arg3. They could be backwards as they are here. And when I run it, arg1 gets 5, arg2 gets 2, arg3 gets 3, and everything comes out accordingly because they're matched by the names. Now, this is how we might handle variable arguments if the function is just worried about them being positional. So in this case, I'm going to say, I don't know how many arguments they're going to give, but however many they give, print them out, starting with an index of 1. So arg1, 2, and 3 is 2, 3, and 5. That could be 6. Again, now everything's variable, doesn't matter. And with KW args, we can do somewhat the same thing. In this case, I'm going to send you a dictionary of 3 elements, and I'm going to process them. You don't know how many you're supposed to get, but you're just going to process everything in the list. And by the way, this is a for loop on how you handle a dictionary. You basically get the items, and you iterate over them, and it gives you a key and a value. And then we use those to just print out a nice message. And we do that. Any questions? It's okay to interrupt me. So if we go back to the question, how do we make a constructor that takes different sets of arguments? Well, we could use this method, basically say, if the KW args contains title, then use the KW args. Otherwise, just set it to none. So this is sort of like an assignment with an if that says, if it's not there, just set it to none. And when we run it, we do that. And it's title, author, copyright, but this one only has title and it's none. Now, I don't think this would persevere if I said, well, it did. If there's no title and it works, yeah. Because I think if you do this, you get null, you get none, null.
I think we may have lost Mr. Knight.
He suddenly disappeared.
Let's wait a few seconds and see if he'll join back. You're muted.
Yeah, sorry about that. I disappeared. Let's see if I can get us back. Okay, so the answer is that it's not the name KWR, it's the function of the star and the star star that matter. And that's kind of the end. However, I was going to also show you this. I said there was a special names. This has to do with the width. So if you look in here, okay, we can look up. So here is the using it with the width block. These are the methods you would have to implement right here and here, as I said. But you can do really crazy stuff, like if you go all the way to the top of this, we can change the way it behaves when we do a string conversion. We can specifically make our class that creates a string of itself in a very particular way. We can create an iterator. Remember when I talked about range and how in 2x range was implemented to give you a list of ints, and in 3 it gives you something that's iterable. This is probably how it achieves that with these functions. So range probably implements an object that implements these functions and makes it possible to do a iteration over the set without actually instantiating every element. And then if we go to the very bottom of all these crazy functions, we can change what equality means for certain classes, certain objects, or their serialization, or constructor. We can change the way the constructor works. And there's that under dict thing again, but we couldn't get it to work. But as you can see, the type of X, you can get a dictionary and get all the different things about, oh, you can mess with its property value. So instead of saying object.color, you can have it do a get in some other strange fashion and to just give you the color back. It could be calculated, which is like a function, but it's an attribute now that behaves like a function. So that's kind of it. I think we're close to done. Questions? I'd like to take some questions to drive the conversation. That'd be fine.
I got a question for you.
Yes.
Say you have 3 things that you want to make a class for, and they all have a certain properties in common. Isn't there a way? I know you can do it in C++, and C sharp. Can you make an object of say you have a class called info, and it basically has the name of the thing, the copyright date, and the date it was last published. Now, that could be a book, a magazine, or any number of things, right?
Right.
Those three would all have those three properties. Okay?
Mhm.
Now, a magazine would also have a month, a publisher's month, a volume, and a number within that volume that's unique to a magazine. A book might have an ISBN number
Right.
that's unique to a book. You see what I mean? But how can you divine? You can do it in C. You would do it with C++. You'd do it with a subclass, an inherited. In other words, you'd inherit from say you call the item. Say you have a class called item, which gives you the base parameters. Could you? I think you had an example. What I was,
Yeah, I was
talking
looking at
about.
it. Is it this one?
No, it's
So this is the base class, and these are the classes that derive from it.
right. Citable. Okay, that's that. Okay, citable source. Now, to get the items from citable source in the book, don't you have to call the citable sources constructor to get
Well,
its parameter?
Here I'm calling it explicitly. Here I'm calling it explicitly.
Okay, I did. Okay.
But here I didn't, and it didn't care.
No, but I think.
You know why? I think because as long as you don't have a constructor, it will call the base one. Let's see if that's true.
I don't know.
Does this?
No.
Oh.
You have an attribute.
Yeah, because.
No, you had it right the first time. Back up here. Back up here.
Yeah.
A citation has. You have to have the parameters. If you don't pass the parameters, it won't go down. And once you passed.
I have to call this explicitly.
Yeah.
If I don't, it doesn't get any value assigned, and then it fails.
Yeah.
So
Right,
because
it
what
doesn't
happens?
get any of the things created in the init.
It's
Right.
it's not constructed.
Yeah.
And the only reason it works. The only reason it works is because there's none at all. So it must be smart enough that if I don't have any init, that it just uses the init of the base class. But if I put an init in here, then I have to explicitly call the init of the base class.
Yeah, and that's done with a function I think called super.
Um,
In the book class, you would call super. First, you would call super. The first thing you do, yeah, super, and then the name of the base class. You don't have to say init, .init. It knows that when you. I think that's how it's done. We went through this in class recently, so in my class that I'm taking.
I get it. It's just you never know.
I just don't. Oh, I think you're about to crash. You just crashed your, what do you call it?
So here it looks like it just uses it like you call in the base class. In other words, I could have called this animal. See, animal? I could have just called this animal and called it direct.
Yeah, but you can say super, and then the name of the base class. And it knows, okay, if there's an under init for that, to call it. I think that's how you do it. That way, A can get from B, and C can get from A, with a different set of added parameters. You understand what I'm saying?
I think so, but I know that works.
It automatically, the init is passing self as the first parameter, itself as a first parameter when it goes to, and book is received, the self that book is receiving is the one created by, if you use super, I think what happens is the self that book receives is the one created by citable material, the initial init, dunder init. All right, I think that's how it's supposed to work.
Oh Lord, you can use it for multiple inheritance too. I don't really want to talk about that.
Oh, don't create issues.
Everybody fell out of love with that shortly after C++ did it.
Yeah. In
await
Python, I think you want to try to avoid it.
Are await and async software interrupt handlers? I don't know, because I don't normally do a lot of asynchronous in Python, mostly because the GIL, which is the global something lock,
The global interpreter lock.
Global interpreter lock. And the way it works is it's kind of cooperative multitasking, and doesn't really do a great job in that. So
yeah, if it wasn't cooperative multitasking, then iterators, I think, wouldn't work the way they do.
Yeah, there would be that issue too.
But
they sort of bailed on that. Now you can get around that. There's a package called Dash, and what it does is it lets you do multi-processing across machines. In fact, not just on the same machine. And what it does is it's task-based in the sense that, oh, I got this to do, and you ship that off there, and ship that off there, and ship that off that way. And then when they're done, they come back, and it pickles. It uses pickling, which is a form of serialization. So it serializes the Python objects across the IPC mechanism.
Serialized package.
Yeah. And then when it gets back the data in pickled version as well.
I hope I don't ever have to learn about that stuff.
Yeah.
I'd like to avoid it. It sounds like I would like to avoid it as much as possible.
You could probably also use MPI for Pi. And I wouldn't doubt it, which is particularly cross-machine if it's MPI. But there's probably some sort of version that does OpenMP as well. Is it still the #1 language for programming AI? Yeah, it seems to be the one everybody uses, yeah. Most people aren't really thrilled with using it for using anything else. I have a coworker that actually tried to compile the whole TensorFlow software package so that they could use it in C++, and they weren't real pleased. It was hard.
We have about 5 minutes left.
That's okay. We got to be here after that too. So, man.
My question about the await and asynchronous software is because I've written some thread processing software in C++.
Right.
And so if I was going to do that in Python, basically I'm sending a message from a mobile device into another machine, basically. And so the Python would be running, waiting for a message from outside, but not really waiting, because it's doing stuff in the meantime that it needs to do. And I don't want to have these as separate programs multitasked by Linux. I'm used to working more in a self-contained program. So
Sounds like,
I don't know what threads support Python has.
I don't
Or
think
should
there's
I
really
just
great threading.
should I just use the multiprocessing of Linux?
thread, there's a thread, there's an actual module for threading. I thought,
Okay.
I was looking,
Yeah, but it can't possibly work that well if it uses the GIL, right? Because
no, it's a, well, here's an example of how to do it without the GIL doesn't interfere with threading. GIL interferes with multi-processing. Threading is all from one. Threads are not separate processes.
Right.
So the GIL has nothing to do with threading, I think.
okay,
But you're thinking multi-processing, like for example, processing requests on a processing requests through mod Python on Apache. That can get screwed up by the GIL if you're not paying attention. If you don't,
What's the GIL?
It's called the acronym is actually the Global
I got it up here.
Interpreter Lock.
Python has common resources inside that it has to provide serial access to, and so it uses a lock internally.
Yeah, it's one lock per interpreter.
I put it up on the screen if you can read that here.
Yeah,
I guess the
it's hard
question
to read that.
I guess the question comes down a little bit to what is the best language for particular applications, and maybe Python is not the best language for real-time applications.
Maybe not, but what you might do is you could use C++
Yeah.
to do all the heavy lifting and computation, and then the Python could be basically polling some resource that you have that services up the asynchronous part.
How do you pass information between a Python program and a C++ program?
There's a whole there's a whole mechanism.
There probably is. You could probably use Python to do it. You could use Python with Python to provide an access to.
That's
Well,
right.
so I know this. I know you can call C from something called Win32. It's a package.
Okay.
I do it all
That's
the
for
time.
Windows only, though.
Yes.
Linux,
that is
Linux does it. Linux does it differently, but
they must have something for SOs.
Yeah, what you do is you wrap the library with some special code. You'll wrap the functions in the library with special code.
Swig. It's called something like Swig.
Swig is the way you create those connections. Yeah,
Thank you.
I think that's what it was called. But yes, you can call C from outside of Python. But Linux in general is not real time. Never mind Python.
In fact, I think Swig does all kinds of different interfaces. JavaScript, Python. There's a list. Java.
Yeah, you can connect language A with language B.
Yeah.
Well, multiple different ways.
And
That's
if
what I
it's
understand.
Linux, there's always standard in and standard out in text.
Yeah, I think it might depend on the volume of the data that you're passing and how fast you're passing it.
Sure, of course. And
Yeah,
the
but
faster it is, the more you better write in C++.
But the issue becomes yeah, it's hard to deal with real time when the operating system is not, the operating system Linux is not deterministic is the term I think they use.
Well,
It's
well,
not deterministic.
actually, the
Like an
Python language
RTOS.
isn't.
An
Yeah.
RTOS is.
Yeah, but even Python's not deterministic because it uses garbage collection. You never know when the program's going to just stop and start collecting stuff and stop doing whatever it was doing.
Actually, interesting enough, you can control that to a point, actually, because there's a module called, I think it's called GC. That's the guy which allows you to somewhat control the garbage collector. I'm reading all these module descriptions. Look up the.
Okay.
Yes, in other words, if you've got a time, you can turn off, disable and enable garbage collection for a certain amount of time. And you can query whether it's enabled or not. You can check to make sure you left it enabled, and you can force it to collect. You see those, I'm looking at the thing you pulled up.
Yeah. Yep.
Can you roll that down a little bit?
Tell me where to stop.
Stop right there. You can tell.
I'm sorry, did you say go up?
Yeah, that's fine. So you can do all kinds of things to keep to. First of all, you can check. You can find out how many objects are hanging there. So
Right, but then that's going to become a whole other thing you're going to need to manage manually.
Yeah, or write another algorithm.
No
just to handle.
It's no different. It's no different than C and C++ malloc.
But
Wow.
garbage collection is only one
You
process.
still have to. You still have
There's all other kinds of processes.
malloc.
True.
Like I would just like to have a no timeout for a little bit of code that I would want to run for knowing that I had the processor completely. Perhaps MicroPython or CircuitPython has some of that.
Actually, CircuitPython doesn't do that. I can tell you that much. I've been working with the. We just finally added async IO module. Time for next.
I think we're there. Oh,
Yes, we are. We're 5 minutes out from the start of.
Is that Charles talking? Because your camera is pointing up the ceiling.
Oh dear. Yes, it is me. I forgot I tilted the.
let's see. The event portal says 2:35. You can't ask any questions until 2:35. I'm just kidding.